All right, this section we're going to learn about two parallel lines cut by a transversal, but we need to do a little bit of vocab first. Let's talk about a transversal. A transversal just is a line that intersects two or more lines. So if I have line M and L, the transversal would be T. It will intersect two or more lines. What happens is we create certain things. We have the interior of the two lines, and we have the exterior. It's pretty basic. If you have your two lines, anything on the outside is the exterior, anything in between is the interior, okay? So let's look, and let's see if we can find some angle pairs based on these names. Let's look at based on these names. So consecutive interior angles. If we look at the word interior, that means it needs to be in here or in here, right? So there's my only four interior angles, 3, 4, 5, and 6. We need consecutive. What consecutive means is consecutive sides of the transversal. So see, 3 and 5 are consecutive. They're on the same side you made here, but we want to use the word consecutive. So angle 3 and angle 5. Then I have angle 4 and angle 6 because they're on consecutive sides. Now I want to jump real quick. I want to go to alternate interior. Let's stay on the inside interior. They're alternate interior angles. That means they're on alternating sides. So 4 and 5. And then the other one would be, yes, angle 3 and angle 6. Alternate exterior. So exterior has to be these or these. They're on the outside. But I want alternate exterior angles. So they're on alternating sides of the transversal. So 1 and 8, 2 and 7. So alternate exterior angles. They have to be on the outside. They have to be on the exterior. And they alternate 1 and 8, 2 and 7. And last, I have corresponding angles. Okay, so for something to correspond, right, to correspond, it's from, if you moved it, it would be on that same spot, okay? Things that correspond, right? This corresponds to that, right? If you moved it, it would be in that same place. So all corresponding angles means is if we took these four angles and I dropped them down to these four, where would they fall? Well, 1 would fall on 5. 3 would fall on 7. 2 would fall on 6. 4 would fall on 8. And it can go the other way. You can also do it that way, right? Vice versa. So my angles are 1 and 5. My angle pairs, angle 1 and 5. Angle 3 and 7. Angle 4 and angle 8. And then angle 2 and angle 6. Okay. It's very important that you learn all four of these pairs, right, and how to identify them. That's the most important thing from this video, is to know all four of these pairs and how to identify them. Okay. These four pairs, when you take parallel lines, they have something special about them. So let's look. Okay. I have two parallel lines. A is parallel to B. To show parallel, you can draw a double arrow to show that those lines are parallel. All right. Now, there's something special about them. Let's look at corresponding angles, the corresponding angles theorem, where we are going to always say if two parallel lines are cut by a transversal, then corresponding angles are. Well, 130 corresponds to 130. 50 and 50, 50 and 50, 30 and 30. See how all corresponding angles are the same exact angles? That means they are congruent. All corresponding angles are congruent. Their measures are equal, the angles are congruent. And shorthand, we're going to do it like this. You're going to write it out like this. If two parallel, we use a parallel sign, dot, dot, dot. So that means if two parallel lines are cut by a transversal, corresponding angles are congruent. That's going to be our shorthand for that one. Let's look at alternate interior angles. Alternate interior. So interior, it has to be these four. If they're alternating, 50 and 50, 130 and 130. Same thing. Alternate interior angles are congruent. Again, if two parallel lines, alternate interior angles are congruent. There's our shorthand for that. Let's look at alternate exterior angles. They're on the outside, so it's got to be these two and these two, alternating. 130 and 130 are alternating. 50 and 50 are alternating. As you see, they are also congruent. If two parallel lines, alternate exterior angles are congruent. And lastly, we have consecutive interior angles. Let's look at the consecutive interior. They gotta be interior. 50 and 130. 130 and 50. What do you notice about them? They both add to 180. So if two angles add up to 180, they are supplementary. So if two parallel lines are cut by a transversal, consecutive interior angles are supplementary. There's my shorthand. Okay, so make sure you have these shorthands under control. Let's look at what a problem may look like. We have to solve for x here. We always have to explain. So what can I set up? What do I know about these two angles right here? They are, let's see, are they interior or exterior? Well, that's an exterior, and that's an exterior. So if they're both exterior, let's see, our only choice is alternate exterior. Are these two alternate exterior? Yep. So 11x minus 20 equals 7x plus 12. Because if two parallel lines are cut by a transversal, alternate exterior angles are congruent. We'll solve it out. 4x is 32, x is 8. Let's see, 7 times 8 is 56, plus 12, 68. 11 times 8 is 88 minus 20, 68. They both work. Okay? So you have to set up your equation and give the reason, just like we were doing before with segment addition postulate, angle addition postulate, et cetera, et cetera. All right, so we look, you guys have 1, 2, 3 things to do on your own. Then the rest of these are in class. We're going to do these together in class. So you have these 3 students complete. Here, it's just, what's the relationship? So if I said angle 1 and angle 9, what is their relationship? They're corresponding angles. That's all I want to know. They're corresponding angles. So tell me what's 4 and 11? What's 7 and 14, et cetera, et cetera. All right, guys? Remember, it's parallel lines cut by a transversal. Make sure you know all 4 and can identify them. All right, Joe.